In our last lesson, we looked at how to write a function rule from a table that was already filled in. In this lesson, we're going to figure out how to come up with the solutions when we've been given a function rule. When we have equations that have one variable, let's think about how many solutions that we can find to those kinds of equations. For example, if I gave you the equation x plus 2 equals 6, what can x be? Well, if I take away 2 on each side, I get x equals 4. There is only one possible value for x that will make this true. 4 plus 2 is our only option to get an answer of 6. Let's consider the equation negative 2x minus 3 equals 5. When we solve that equation, we'll add 3 to both sides, giving us negative 2x equals 8. We divide by negative 2, and we get an answer of x equals negative 4. Negative 4 is the only solution that we can put in place of x that will give us the correct answer of 5. When we have an equation with one variable, we can find only one right answer. Now, let's look at equations that have two variables in them, and let's think about the solutions that we get in this case. So, let's say we have an equation that is x plus y equals 8. Let's think. What are some options for x and y? X could be 1 and y could be 7. 1 plus 7 is 8. X could be 2 and y could be 6. 2 plus 6 is 8. X could be 3. 3 plus 5 gives us 8. X could be 4 and y could be 4. 4 plus 4 gives us 8. X could be 5 and y could be 3. This list could go on for quite some time, right? How about the equation x minus y equals 10? Let's consider some options. If x was 20, 20 minus what would give us 10? Well, 10. 20 minus 10 is 10. If x was 19, 19 minus what is 10? Well, that would be 9. 19 minus 9 is 10. How about if x was 18? 18 minus 8 would be 10. What about if x was 17? Y would be 7. 17 minus 7 is 10. I could go on and on for some time, right? It's important for us to understand there's a very big difference between an equation with one variable, which has one right answer, and then equations that have two variables. There's a lot of solutions, right? My list here could go on and on and on. So let's summarize what we just said. Equations with one variable have one solution. Equations written with two variables, we figured those lists could go on and on for a long time, right? Well, in reality, the truth is those lists could go on for forever. Equations written with two variables have an infinite number of solutions. There's no end. We could go on and on for forever finding right answers to equations that have two variables. Now, let's consider an equation and let's test an ordered pair to see if it is a solution. Okay, remember in an ordered pair we have an x coordinate and a y coordinate. We have an input and an output. We have a domain and a range. We have an x and a y. So let's see if negative 2, 5 is one of the infinite number of solutions that would go with this equation y equals 3x plus 1. In order to do that, let's take our y coordinate and plug it in right here in place of y. 5 equals 3. Let's take our x coordinate, put it right here for x, times negative 2 plus 1. And let's solve that. 3 times negative 2 is negative 6. So on the right-hand side, we have negative 6 plus 1. And here on the left-hand side, we still have 5. Negative 6 plus 1 is negative 5. So we have 5 equals negative 5. Is that true? No, 5 does not equal negative 5. So negative 2, 5 is not a solution to that equation. Now there's an infinite number of correct solutions, but negative 2, 5 is not one of them. Let's see if 1, negative 2 is a solution to this equation, y equals 2x minus 4. Remember, we have an x-coordinate and a y-coordinate. Okay, let's take our y-coordinate and plug it in for y. Negative 2 equals 2, take your x-coordinate, put it right here for x, minus 4. So let's solve. 2 times 1 is 2, so we have negative 2 equals 2 minus 4. 2 minus 4 is negative 2. So we have negative 2 equals negative 2. Yes, that's correct. Negative 2 equals negative 2. So 1, negative 2 is one of the infinite number of correct solutions to the equation y equals 2x minus 4. So we just tested ordered pairs that were already given to us. What if we have to find them ourselves? Okay, what if we need to find the solutions? A very simple way to do that is to create a chart like you see here. Okay, and then choose 3 numbers for x. Remember, there's an infinite number, so we can't find all the x values and all the y values, but let's just choose 3. So I'm going to choose pretty small numbers since it's easy for us to do math with small numbers. I'm going to choose 0, 1, and 2. Okay, and then I'm going to take those x values and I'm going to plug those in to the problem here. Negative 2 times 0 plus 3, and then I'm going to solve that. It says in our problem y equals negative 2 times x plus 3. So let's find out what y is if we plug in 0. Negative 2 times 0 is 0. 0 plus 3 is 3. Let's plug in 1. Negative 2 times 1 plus 3. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. Let's find out what y is if we plug in 2. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. So we found 3 values for x and y that would satisfy this equation. Now remember, how many possible solutions does this equation have? Well, it has an infinite number of answers. We just chose to find 3 of those answers. We found 3 x's and 3 y's that'll work in the equation y equals negative 2x plus 3. Now remember, here's the chart we just made on the last page, okay? We got answers of 0, 3, 1, 1, and 2, negative 1, okay? Remember, there's an infinite number of right answers. We just happen to get those 3 x and y values, okay? Where else do you remember seeing x and y? We see them in ordered pairs, right? In an ordered pair, we have an x and a y value, right? What that means is that we can take the solutions to these equations that have 2 variables, and we can write our solutions as ordered pairs. So the answers we found just a moment ago can be written as 0, 3, 1, 1, and 2, negative 1. Anytime we find a solution to an equation with 2 variables, we can write that answer, we can write that solution as an ordered pair.